Hello everyone. Let us discuss fundamentals of a computing. What is a computer? A machine that carry out any computational task. Is it really? Yes. It is formally proven that a computer given sufficient memory and time that can carry out any computational race. But how? For this we look inside a typical computer. Inside a PC, there consists of a power supply, drive bays, and expansion slots. And inside the motherboard, it consists back panel connectors, expansion cards in the PCI and slots, and storage drive connectors, memory in memory slots, CPU in CPU socket. And there are different types of functional units. Example, CPU memory hard disk. CPU means central processing unit. It consists of arithmetic logic unit, control unit, which execute instructions, and there is memory which is used to storage of the area quickly accessible from the CPU, and there is a hard disk storage. It is used as a storage area, but it is not so quickly accessible from the CPU. And there are different devices, input and output devices, that we have already know. And let's go into the binary format. In a computer, everything is stored in binary format, a sequence of zeros and ones. The components of a computer understands only binary format. Number 4 is stored as 0100, and number 1 is stored as 0001. And execution in a computer. To begin with, all the data and commands related to the computation is stored in memory. Commands are then brought into the CPU through the bus, one at a time. Each command is executed inside the CPU in the following ways. If the command requires data, it is brought to CPU from memory. Command is then executed using the data. The command may be for storing data present inside the CPU to memory. A program is a collection of commands. Let us discuss a small program. Here, first code reads memory location 001, and in the second binary code, it will read memory location 010, and the third, it will add two numbers and will read. And in the fourth binary code, it will store the result in the binary location 001. Let us see the execution. In this step 1, it will bring 001 location to CPU. It will bring the data. And in the second step, it will execute in control unit, which it already got from the first code. And in the step 3, it will bring data stored in memory location 010 to CPU. And in step 4, execution of the second code in its control unit will occur. And in the step 5, it will bring the third code, which is used to add two stored numbers. And in step 6, execution of the adding two numbers will occur. It will add first first location number and second location number. And in step 7, it will stores number in ALU to memory location. And in step 8, execution of the fourth code, that is, it will stores data stored in ALU number 5 in location number 1. Let's go into the assembly language. It is very difficult for us to understand this binary language called machine language, and this is the only language that computers understand. To make it more readable, assembly language was introduced. In assembly language, operations and memory locations are addressed by names. Naming locations in example program num1 and num2 are the two location names that we have given, and r1 or r2 are the location name that is given to control unit. And we name memory and CPU locations in different way. Example program in assembly language. Here, which we already seen, the first code which represent reads number 1. In assembly language, we can written as move num1, r1. And for the second code, we can read as move num2, r2. And in the third code, adds r1 and r2. In the fourth, it will move r1 to num1. Move contents of memory location num1 to CPU register r1, which we have already seen. Let us discuss assemblers. An assembly language program eventually must be translated to machine language. An assembler does this job, which will translate assembly language to mission language. It maps the names to the corresponding binary values. It is also a program. Input output. The example only shows how to add numbers already present in the memory. How does one add numbers provided by the user through the keyboard? This is the job of another program called the operating system, OS in short. OS picks the input given by the user and store it in the application location of memory. It also picks a result of computation from memory and displays to the user through monitor. It does many other housekeeping jobs that make the interaction of users with computer easy. And there are different types of OS like Linux, Windows, Mac OS, etc. Need for a better language. It is very difficult to write large programs in assembly language. Several languages were created during 1960s and 80s to simplify the task of program. The prominent ones are COBOL, Fortran, Pascal, C. These are called high-level programming language. Assembly and mission language are also called low-level programming language. And there are some example codes for adding two numbers in C, and it is a sample code we can write in C language. And and there is another thing which denotes the beginning and the end of the program. And here we can say it will names a memory location. This is the code which explains step-by-step process. And let's go to the compilers. A C compiler translates a C program to a mission language. There are many C compilers. We will use one called CLang. Let us see how to debug. Here it is a VS Code where a sample code is written, and in the terminal we have entered debug 50 space sum, and sum is a file which we have written the code. But after running this code debug 50 space sum, it will execute in this manner. Here we can check each and every step-by-step process. We can edit, we can go to the retro, we can stop, we can solve our missed errors in debugging process. Let's go to one more thing called CS50 duck debugger, which is present left side CS50. When we select CS50 duck debugger, we can use it like a copilot where we can ask any questions. It will answer it in a very good manner. Example, we can see that in the left side, it shows how can I debug my sum.file, and it shows